Introduction. Hello and welcome to this video on linear regression. In this video, we'll be discussing what linear regression is and its significance in data analysis. Linear regression is a statistical method used to model the relationship between two variables, with one variable being the predictor or independent variable and the other being the response or dependent variable. By understanding this relationship, we can make predictions about the value of the response variable for a given value of the predictor variable. Simple linear regression. Let's start by discussing simple linear regression. Simple linear regression involves modeling the relationship between a single predictor and a response variable. This is useful when we want to understand how a single factor affects the outcome of interest. To calculate the regression equation, we need to find the slope and intercept of the regression line. The slope represents the change in the response variable for a 1-unit increase in the predictor variable, while the intercept represents the expected value of the response variable when the predictor variable is 0. We can interpret the slope and intercept of the regression line to understand the relationship between the predictor and response variables. For example, if the slope is positive, it means that as the predictor variable increases, the response variable also increases. If the intercept is negative, it means that the expected value of the response variable is lower when the predictor variable is 0. Multiple linear regression. Now let's talk about multiple linear regression. Multiple linear regression involves modeling the relationship between two or more predictor variables and a response variable. This is useful when we want to understand how multiple factors affect the outcome of interest. To calculate the multiple regression equation, we need to find the coefficients of the predictor variables. These coefficients represent the change in the response variable for a 1-unit increase in each predictor variable, while holding all other predictor variables constant. We can interpret the coefficients of the predictor variables to understand their individual effects on the response variable. For example, if the coefficient for a predictor variable is positive, it means that as that predictor variable increases, the response variable also increases, while holding all other predictor variables constant. We can also use the coefficient of determination, or R-squared, to assess the overall fit of the regression model. R-squared represents the proportion of variance in the response variable that is explained by the predictor variables. A higher R-squared indicates a better fit of the model to the data. Assumptions of linear regression. It's important to note that linear regression has several assumptions that must be met for the estimates to be unbiased and accurate. These assumptions include linearity, homoscedasticity, independence, normality, and absence of multicollinearity. Linearity means that the relationship between the predictor and response variables is linear. Homoscedasticity means that the variability of the response variable is constant across all values of the predictor variable. Independence means that the observations are independent of each other. Normality means that the residuals of the regression model are normally distributed. An absence of multicollinearity means that the predictor variables are not highly correlated with each other. If these assumptions are violated, the regression estimates may be biased or inaccurate. Therefore, it's important to check for violations using diagnostic plots and to consider alternative regression methods if necessary. Applications of linear regression. Linear regression has many applications in various fields, such as predicting sales based on advertising expenditure, estimating the impact of a new drug on patient outcomes, and modeling the relationship between climate variables and crop yields. By using linear regression, we can gain insights into the relationships between variables and make predictions about future outcomes. It's a powerful tool in data analysis that is widely used across different domains.